All right, this is our second day of getting common denominators. So today we are going to take the two rational expressions, we're going to get a common denominator, and then we're actually going to go through the process of combining those two fractions and simplifying the entire thing from start to finish. All right, so I have several examples for us. We'll see how many we can get through without making this video too long. So first example, 4x over 4xy minus 6y over 4. So for our first fraction, our denominator, we have a 4 times an x times a y. This one is pretty straightforward, I feel. You can kind of see the pieces pretty easily. So between the two, we definitely need a 4. We definitely need an x. We definitely need a y. So the first fraction has everything. We don't have to adjust that fraction at all. We just have 4x over 4xy. The second fraction only has the 4. So we're going to need to multiply by xy on the top and the bottom. All right, so I'll go ahead and write down what I have. So 6xy squared. So at this point, I'll go ahead and write down everything written as one fraction with a common denominator. And then before I can cancel things, I need to go ahead and factor. So the top is a binomial. That means my method for factoring is going to be to take out a GCF. Between 4 and 6, I can take out a GCF of 2. And then with the variables, I have a GCF of x. I know that I've written this in a way that is pretty drawn out, but my writing it in all these steps is keeping me from making mistakes. So I encourage you guys, take up space when you write your work. If I don't leave you enough space on a worksheet, then go ahead and use a separate sheet of paper. Don't shorthand things until you are really good at doing these problems, until you get them right every time. And then after you're getting them right every time, if you want to start to shorthand, you can. Some of you guys start to cut out steps too early, and then you start getting your answers wrong. All right, so I divided the top and the bottom by 2, my x's canceled out, and then there was my final answer. All right, next example, we have 2/3 minus 5x plus 5 over 3x minus 15. So that first denominator, pretty easy, that's just a 3. That second denominator is a binomial, so we need to factor that one. It has a GCF of 3, and then in parentheses we have x minus 5. So with the common denominator, I can see that we definitely need to have a 3 in our common denominator, and then we also need to have that factor x minus 5 that we found in the parentheses. So the first fraction needs the parentheses of x minus 5. The second fraction doesn't need anything. It had the entire common denominator. So it just gets to stay as is. All right, so next I'll go ahead and write down what I have. Again, I'm doing a really good job of showing my work so that I don't make little mistakes, especially when the math is new to me. So now I'm going to write it as one fraction with a common denominator. 2x minus 10, I'll distribute that negative, minus 5x minus 5. So 2x and negative 5x makes negative 3x. Negative 10 and negative 5 makes negative 15. So 3 and then x minus 5. Okay, So before I can start to cancel things, I'm going to have to factor this. So between 3 and 15, the GCF is 3. Since the leading term is negative, I have to take a negative out. So negative 3, that leaves me with an x plus 5. 3 on the bottom, x minus 5. So the negative doesn't cancel, but the 3's do. All right, so my final answer, I've got a negative on the top, x plus 5, and then on the bottom, x minus 5. It's very tempting to cancel those out, but they are not the same. So that's my final answer. Some people would leave it like that. Some people would distribute the negative to the top and get negative x minus 5. It is even more tempting to cancel them out now, but they do not cancel. So either one of those is a good answer. They're both equally accurate. All right, let's do another example. We've got 11p minus 4 over 6p squared minus 3p minus 4 over 3p. So for that first fraction, we have a binomial in the denominator. We have to factor that by taking out a GCF. The GCF is 3p. That leaves us with 2p minus 1. For the second fraction, the denominator is just 3p. So for the common denominator, we would have 3p times 2p minus 1. And so that means the first fraction has the entire denominator. I don't have to fix anything about that. The second fraction has the 3p, but it needs the 2p minus 1. It needs the parentheses. You'll notice that my examples are mostly subtraction. I think they all are at this point. In fact, all the examples on my page are subtraction because those are the most difficult for students to get correct. So you'll see a lot of those. Addition problems are easier. All right, distribute the 4. We get 8p minus 4. All right, so now I can go ahead and write this as one fraction with a common denominator. So I've got 11p minus 4, distribute that negative, minus 8p plus 4. So my 4's cancel, and I have 11p minus 8p, which gives me 3p. So I have 3p on the top, and then on the bottom, 3p times 2p minus 1. So we actually didn't have to factor anything since those the 4's canceled out. So now the 3p on the top and the 3p on the bottom actually cancel. And a lot of students have been getting these types of problems wrong. A lot of students are like, oh, the answer is 2p minus 1. That is not the answer. Whenever something cancels and you have nothing left over on the top, it leaves a 1 behind. The answer here is 1 over 2p minus 1. All right. And I think I'm going to go ahead and leave it there for the video.